Now we'll go for e to the power y plus 1 cos x dx plus e to the power y sin x dy. We are going to solve this. Okay, as usual I have written the same thing and I have brought this term to that side, to the right hand side. So e power y, I am going to bring this term to left hand side as a denominator. So this term, they involve only x, and I have brought this term to right hand side, they involve only x. And what of this term? The integration, after integrating you will get ln e power y plus 1, correct? 1 by e power y plus 1, answer will be e power y. See, when you are going to differentiate, you will get 1 divided by e power y plus 1, again e power y dy. See, you will get this. So when you are going to differentiate, this will be 1 divided by sin x, 1 divided by sin x. Sin x, when you are going to differentiate, you will get cos x. See here, cos x. Plus here also ln, so ln c. Log rule, you apply log rule, you will get this, and ln will cancel, you will get required answer. Okay, any doubt? Okay. Now secant squared x tan y dx plus secant squared y tan x dy. So this is the given equation. Just take this term to right hand side, you will get this. Okay, then you keep secant squared y as it is, you bring this tan y to left hand side, and this is in terms of y terms alone. We have separated using separation of variables. This term involves only x. Now integrate on both sides. So you have integration answer will be ln tan y. As usual, you differentiate, that will give you 1 by tan y secant squared y. Similarly, you have minus ln tan x, you bring this term to this side, again log rule, you apply log rule, then ln will get cancelled, you have tan y tan x which is equal to c. So this is the required solution. So now we'll go for the next problem. X squared y plus 1 dx plus y squared x minus 1 dy equals 0. Okay. Now I am going to take this term to right hand side. So this gives minus sign. So now y squared divided by y plus 1 dy, which is equal to minus x squared. Take this term to right hand side, you will have x minus 1 dx. Okay. Now I am going to add plus 1 and minus 1 here. I am going to add plus 1 and minus 1. So here also plus 1 minus 1. So this equation becomes y squared minus 1 plus 1. This becomes x squared minus 1 plus 1. So this can be written as y plus 1 y minus 1, correct? Y squared minus 1 can be written as y plus 1 y minus 1. X squared minus 1 can be written as x plus 1 x minus 1. And I can write separately. This as like this and this as like separately I can write. See, I have written separately. Here also I can write separately this term and this term. I have written separately. Now I am going to integrate. Okay, integrate on both sides. So y plus 1 will get cancelled. You have the first term will be y minus 1. The remaining one will be integration of 1 divided by y plus 1 dy. Similarly, these two will get cancelled. You have x plus 1 and y 1 divided by x minus 1. I can write like this. Now integrating. Integration answer will be y squared by 2. Integration of 1 will be y. Correct? Dy. See, integration of dy. Answer will be y. And what of this one? Ln y plus 1. Integration of this one will be x squared by 2. This will be your x and this will be ln x minus 1. See, we have separately written y and x and we have solved the problem. So this is the required solution. So now we will go for another problem. 1 plus x, 1 plus y squared dx plus 1 plus y, 1 plus x squared dy. Okay. As usual, you just bring this term to right hand side. So now 1 plus y, you keep it as it is. 1 plus x squared, I can bring this term to this side. You have 1 plus x is here. Okay, 1 plus x is here. You just take 1 plus x squared to right hand side. We have separated now y term and x term. Okay, like this. So now we can write this term as 1 divided by 1 plus y squared, y divided by 1 plus y squared. I am going to multiply and divide by 2. See here, 1 divided by 1 plus y squared. Separately you can write. This can be written as plus y divided by 1 plus y squared. Multiply and divide by 2, because when I am going to differentiate you will get 2y. Similarly, You just separate this one and just separate this one. You can write this as x divided by 1 plus x squared, multiply and divide by 2, you will get this. Again we are going to integrate, differentiate, you will get 2x here. So that's the reason that we are multiply and divide by 2. So 1 divided by 1 plus y squared integration with respect to y will get you tan inverse of y. When you are going to differentiate tan inverse of y, answer will be 1 divided by 1 plus y squared. Similarly, this can be written as 1 by 2 ln 1 plus y squared. Ln 1 plus y squared, 1 divided by 1 plus y squared, 2y. See, 2y. Similarly, right hand side. So now we have written separately y and x. So this is the required solution. Okay. Now, so as I said earlier, that for any homogeneous equation, there will be no PIs, no particular integrals. Okay, very important. So we have now complete solution will be your complementary function plus particular integral. For any homogeneous equation, there will be no PIs. Suppose the differential equation involves polynomial, x squared is a polynomial. It can involve trigonometry, sin x, sin 3x. It can involve e power exponential term, e power x, or combination of these two. Then we call this as inhomogeneous equation, for which we need to have PIs. Is it okay? We need to have PIs. So we are going to solve 3 more problems. You will understand clearly. Okay, what we say as this equation as auxiliary equation. So earlier for any homogeneous equation we wrote as characteristic equation. Now for any inhomogeneous equation we are going to write this as auxiliary equation. Okay, solution will be your m equals 2, 3 for example. Then complementary function will be, for example, a e to the power 2x plus b e to the power 3x. Okay, for this. Suppose if it is equal to 0. If it is not equal to 0, we are going to solve with PIs. Okay, see now, this is your differential equation. Okay, see there is no 0 here. So it's a homogeneous or non-homogeneous equation. Okay, it's non-homogeneous, inhomogeneous equation. So we have to involve PIs. Don't forget, we have to involve particular integrals. So we can write this as, listen to me, it's very simple methods. There are 3 methods are there. That's all. Okay. So we have 4. We can write this as d squared. 2 times we have differentiated, so d squared. This can be written as 4d minus 3. I have pulled y out, which is equal to e to the power 2x. Out of this equation, you can make auxiliary equation as 4d squared plus 4d minus 3, which is equal to 0. Is it okay? I am going to factorize this one. I am going to write 4d as 60 minus 2d. So I am going to factorize this one. So 60 minus 2d. I can pull 2d out, 2d minus 1, correct? 2d multiplied 2d will give you 4d squared. 2d multiplied minus 1 will give you minus 2d. Here 3 multiplied 2d will give you 60. 3 multiplied minus 1 will give you minus 3. So I have factorized now 2d minus 1 and 2d plus 3. So d equals 1 by 2 and d equals minus 3 by 2. Is it okay? Simple one. So d equals 1 by 2 and minus 3 by 2. What are the complementary function? Roots are not equal. So you have to write exactly c1 e to the power 1 by 2x plus c2 e to the power minus 3 by 2x. The first method which we learnt in the video lecture earlier. Now we will go for particular integrals. Particular integral, you have to write, this is the procedure, 1 divided by, you write auxiliary equation first. 4d squared plus 4d minus 3. What about on the right hand side? E to the power 2x. See here, e to the power 2x, right hand side. You write e to the power 2x here. Okay, you instead of d, you substitute the constant d here. Okay, so this becomes 4, 2 squared plus 4 multiplied by 2 minus 3. Okay, so you have 2 2s are 4, 4 multiplied by 4, 16 plus 8 minus 3 will be 21. So this is your PI, particular integral. You add these two and write the complete solution. So your complete solution y will be complementary function plus particular integral. So this is your complementary function plus particular integral. This will work out only for the inhomogeneous equation. not homogeneous equation. Is it okay? Simple one. So this is one method. So on right hand side we have kept as a exponential. Now we can go with polynomial, we can go with trigonometry, or we can go with the combined one. For all will have different procedures. So this is the first procedure for e to the power 2x exponential. Any doubt? You substitute instead of d, you substitute 2. That's all. Simple idea. Now d square plus 4y which is equal to sine 3x. See here, this is trigonometry one. So sine 3x, trigonometry one. What is the procedure? We'll find out. Now the auxiliary equation is d square plus 4 equals 0. So d squared equals minus 4. So d equals plus or minus 2y. The third type. Imaginary. Correct? Third type. d equals plus or minus 2y. So your complementary function will be a e to the power, your complementary function will be a e to the power 2x. Okay, can you remember the last one? Y equals e power alpha x multiplied by c1 cos beta x plus c2 sin beta x. Sin beta x. Can you remember? Can you remember this one? What about here real number? What are there is no real number. So e to the power alpha x, alpha equals 0. So answer is 1. See, there is no number here. There is no e power alpha x because alpha equals 0. So e power 0 is 1. 1 multiplied by this one. So this is the answer. c1 cos 2x plus c2 sin 2x. Particular integral. As usual, as I said, 1 divided by auxiliary equation. So 1 divided by d square plus 4. This is our auxiliary equation. Multiplied by sin 3x. Now, you have to write for sin 3x, the formula is 1 divided by minus a squared. So here, sin 3 exists. So you have to write minus 3 squared. It is not minus 3 whole squared. Don't forget. It is minus 3 squared. Minus sign exists. Okay, we will get confused with minus 3 whole squared usually. It is not minus 3. It is not minus 3 whole squared. It is minus 3 squared. Minus 3 squared is nothing but minus 9. Minus 9 plus 5 is nothing but minus 1 by 5 sin 3x. So this is the answer for your PI. Is it okay? Don't forget this is minus a squared. It is not minus a whole squared. Always will get confused with this one. So we will have the complete solution will be complementary function plus particular integral. So this is your complementary function. This is your particular integral. So this contains only trigonometry function. Okay. Now we will go for another one. See, polynomial. So earlier we did for e power x, e power 2x. The next problem is solved with trigonometry function. The third one involves polynomial. See now d squared y by dx squared plus 4dy by dx plus 4y equals x squared. So you have now auxiliary equation is nothing but d squared plus 4d plus 4 equals 0. You can pull y out, that will give you d squared plus 4d plus 4y which is equal to x squared. This is your auxiliary equation. So you will have to factorize. So d plus 2 whole squared equal to 0. D equals minus 2 and minus 2. So roots are equal. If roots are equal, second type c1 plus c2 times x e power minus 2x. So this is your complementary function. So now you have to go with particular integrals. So 1 divided by your auxiliary equation multiplied by x squared. So for polynomial, you will have to make the denominator into binomial expression. You just remember this one. For polynomial, you make the denominator so that this denominator will become a binomial expression. I repeat, 1 divided by, I can pull d plus 2 whole square. I can pull 2 out here. D plus 2. I can pull 2 out here. So this will become 1 plus d by 2. 1 2 is there. Squared is there. So I can pull only 4. See here, this is squared. Suppose if squared is not there, then d plus 2. I can pull 1 2 out, means it will be 1 plus d by 2. Simply. The square is there. So this becomes 4. So 4 times 1 plus d by 2 whole square. You bring this denominator to the numerator, you will get this. Now using binomial expression. So you have 1 minus 2d by 2 plus n into n minus 1 divided by 2 factorial d squared by 4. Similarly, you can go for other terms also, but only we need to have only 3 terms, more than enough. So this is your first term, this will be your second term, and this will be third term, and goes on, multiplied by this x squared. So you multiply this x squared, that will give you x squared, 2 will cancel, you have dx squared plus minus minus plus, so 3 by 4, correct? Is it so? These 2 and these 2 will get cancelled, minus minus plus, so plus 3 by 4, you have d squared multiplied by x squared, and goes on. So this can be written as 1 by 4 x squared plus 2x plus 3 by 2. What is this one? Suppose in the numerator, if d is there, in the numerator, if d is there, you will have to differentiate. In the denominator, if d is there, you will have to integrate. You remember this method. If d is here in the numerator, you just differentiate nearby. Suppose if it is in the denominator 1 by d, you will have to integrate. Okay. So what is given here? Dx squared. So you will have to differentiate only once. See, minus 2x. Here d squared is there in the numerator. So you will have to differentiate 2 times x squared. First time when you are going to integrate, differentiate 2x. Again when you are going to differentiate, that will be 2. I repeat, x squared, you will have to differentiate 2 times because d squared is there. So 2x, again 2, you will get 2. So you will get 2, 3 multiplied 2 divided by 4 is nothing but 3 by 2. Shall I repeat? I repeat. See here, you have x squared minus dx squared plus 3 by 4 d squared x squared. This is the final answer we have obtained from binomial expression. Now it involves d. In the numerator, if d is there, you will have to differentiate only once. You will have to differentiate. You will have to d squared is there. You will have to differentiate 2 times. When you are going to differentiate this, you will get 2x. X squared is there. You will have to differentiate only once, 2x. You will have to differentiate 2 times. So x squared, when you are going to differentiate, it will give you 2x first time. When you are going to differentiate again, answer will be 2. C2. This 2 and this 4 will get cancelled. We have 3 by 2. So 3 by 2. The complete solution will be this plus this complementary function. So this is your complementary function, and this will be your particular integral. So this is your complete solution. Any doubt? So which involves polynomial. Okay. Now solve the differential equation. Now look over here. Right hand side, it's very tedious. Now it involves polynomial, exponential, sin x, trigonometry. So earlier we looked at some problems individual, x alone, e power x alone, sin x alone. See, now we are going to have together. So we are going to solve, we will try to solve this equation. So d squared y by dx squared minus 2 dy by dx plus y equals 0. For example, first you will have to take the characteristic equation to get the complementary function, and this becomes d minus 1 whole square. We will have to get the complementary function. So d minus 1 whole square. So d equals 1 comma 1. Roots are equal. So complementary function will be c1 plus c2 x e power x. So this is the first procedure. So we have obtained now complementary complementary function is over now. So now we will go with particular integrals. So 1 divided by your auxiliary equation e power x sin x, correct? X e power x sin x. So you will have to write e power x sin x. Now suppose if it is involved like this, e power x sin x, then you write d plus 1. Instead of d, you write d plus 1. Suppose if it is 2x, e power 2x, suppose. Then you will have to write d plus 2. If it is 3, if it is minus, d minus. Okay, this is the idea. So you have 1 divided by d minus 1 whole square e power x sin x. We have pulled e power x alone here. So e power x 1 divided by, so here the constant is 1. So you return d plus 1 minus 1. This 1 and this 1 will cancel. You have d squared. So e power x 1 divided by d squared. So now d squared is in the denominator. What is the procedure? We will have to integrate. That's the idea. We will have to integrate this function x sin x. See, we have integrated only once. 1 by d squared is 1 by d squared is 1 by d multiplied by 1 by d. So 1 by d the integration. After getting the solution, you will have to integrate again. So now e power x I have written like this, 1 by d as it is. This is u dv method. So integration of u dv equals uv minus v du. So we can write u, this I am going to keep it this as dv. So u dv. So v is minus cos x. See, minus x cos x. uv minus v du minus v du. v du is, see here, u dv, correct? What is du? du is nothing but 1 x dx. When I will differentiate x, that will be dx 1. So you have 1. v is minus cos x dx, and we can write this as e power x 1 by d times, we can write this as x cos x, here x cos x. What about the integration of minus cos x? See, we written minus sin x. So 1 by d sin x minus cos x. We have done. So now we will have to integrate again once. So we will have to integrate e power x, integration of, instead of 1 by d, we will have to integrate. So that will be integration of sin x minus x cos x. So integration of sin x will give you minus cos x, and x cos x as usual u dv method, u dv minus v du. See, u dv minus v du. So you will get e power x, as usual this term will be there, x sin x will be there, integration of sin x will give you cos x, see here you will get. So minus cos x will give you 2 cos x. I can pull e power minus sign out, so minus e power x, x sin x plus 2 cos x. So this is your pi, particular integral. So you have complementary function plus particular integral will give you complete solution. So that's the idea. Any doubt? So now we will go for sin 3x, trigonometry alone. Okay. So d square plus 4y equals sin 3x. As usual, just take the characteristic equation, that will give you d square plus 4 equals 0. So d square equal to minus 4. We have already seen this problem earlier. Okay, we have this, so this is repeated. We have already seen this problem, so we are going to skip this one. Okay. So now this is inhomogeneous equation which involves polynomial and the exponential term. So we have to find out first the characteristic equation, auxiliary equation. So d square minus 4d plus 4 equals 0. Factorize this one, you will have d minus 2 whole square equal to 0. So d equals 2 comma 2, roots are equal. You will have to use the second method, which is nothing but c1 plus c2x e power 2x. Then to find out the particular integral, 1 divided by your auxiliary equation multiplied by x cube e to the power 2x. We can pull e power 2x this side, as I said earlier. Then you have to write 2. So d plus 2. Wherever you find d, you substitute d plus 2. See, d plus 2 whole square minus 4d plus 2 plus 4. D plus 2 whole square is nothing but, you can just expand. D square plus 4d plus 4 minus 4d minus 8 plus 4. This 4d gets cancelled. 4 plus 4 minus 8, answer will be 0. So you will get only d squared alone. You expand this one, you will get only d squared. So e to the power 2x, 1 divided by d squared x cube. You will have to integrate 2 times. You will have to integrate x cube 2 times. D is there in the denominator. So 2 times you will have to integrate. First time you are going to integrate, the answer will be x cube by 3. Second time, x to the power 4 by 4. See, x cube, after the integration, the answer will be x to the power 4 by 4. Sorry, x to the power 4 by 4. After integration of this will be x to the power 5 by 5. 5 multiplied by 4 will be 20. So e to the power 2x, x to the power 5 divided by 20. So this is your pi, particular integral. So your complete solution will be complementary function plus particular integral. That's the answer. Okay, any doubt? So we'll stop here, and we have we have finished about the differential equation, and we have seen 3 types of solution of differential equation. if the roots are equal, if the roots are not equal, and if the roots are imaginary, we can get the complementary function for the homogeneous equation. For the inhomogeneous equation, right hand side is not equal to 0, which can involve either exponential, or it can be polynomial, it can involve, or it can involve trigonometry, or the combination of anything. So we can get the complete solution as the addition of complementary function and particular integral. So we will stop today. Okay. Thank you, students. We will see you in the next class.